Okay, let's move on. Now we're looking at cyclic hydrocarbons. When we started naming alkanes and alkenes, I mentioned something and referred to hydrocarbons as well, but I decided to take them out and say, yeah, let's name them separately. But you'll find the rules that we are using are pretty much the same. There's only a few slight differences here and there, but the majority of the rules are pretty much what we're following when we're naming alkanes and alkenes that have got straight chains. Why do we call them cyclic hydrocarbons? It's because the carbon atoms that make the compound are arranged in a loop. They are connected in a loop. Even though we use straight lines like what we've done here, they are still cyclic hydrocarbons. This is not a circle. It doesn't necessarily suggest a circle, but it's like just saying they are connected in a loop. Whatever shape they form, that's something else. Now, another thing here is you might find books that present formulas like this here, that present structures like this here. What you need to understand with this one here is at the end of every line there is a carbon, right? And this carbon, like for example, if I look at this carbon here, it has got 1-2 bonds, so it means this carbon will require 2 hydrogen atoms there. This is a skeleton formula because it leaves out all these atoms, and then this one here has got 1, 2, so and you need another third one. So you shouldn't freak out when you see something like this here. That's what it is. You can even go in and write those to complete them if you want to make your life easy and understand what's going on. Okay, enough of that one. Let's look at how we name these cyclic alkanes. Right, the first things first is we have to, I'll go right at the start of my PowerPoint, we have to identify whether it's an alkane or an alkene. So we need to choose the correct ending. For example, the ending for this one will be ENE. So we're saying why ENE? Because there's a double bond there. The ending for this one will be ANE. So this one is an alkane, a cycloalkane. That one is a the first two are cycloalkenes. That done, the next thing is we need to find the longest chain. For the curriculum we are working on, or for these videos, which is the Western Australian curriculum, we are not going to come across the scenario that I'm just going to tell you. It's possible that the longest chain might be what is coming out of the ring. Yeah, because I said the longest chain usually is the ring. So the ring, from what we're looking at this stage, always the ring will be your longest chain. We're not going to deal with a situation where, for example, if I have this with 1, 2, 3, 4, 5, I could have had, on this one, I could have had 6 carbon atoms going this way on this side chain. So this one now will cease to be the principal chain. The longest chain will be the 6 carbon atoms, but that's beyond the scope of the WA curriculum or the syllabus you are following at this stage, so we don't need to worry about those. I just thought I'd mention it, but we're never going to talk about those. You'll never see such examples. Now, so having done this, we now need to look at, okay, this one here, the prefix is going to be in. The suffix is in. The prefix is determined by the number of carbon atoms, which is 5. So this the prefix is pent in. With cycloalkenes, we don't need to worry about numbering the position of the double bond, because we know that the double bond will always take the lowest number possible. It's always located on the first carbon. So in this cyclic alkenes, our double bond is by default on carbon number 1, so it doesn't affect it doesn't give us the need to name the position of the double bond. So the prefix, this one here, is pent in, which is cyclopentene. Actually, we call it cyclopentene. Okay, this one doesn't have any side chains, which means the name for that one is alright. Now, this one here is also cyclopentene, pentene, but it has got side chains. Now, how do we go about numbering the side chains? There might be other rules. So like I said, in cycloalkenes, the double bond is always assigned locate number 1 and 2. So what it is they must be numbered consecutively. So if I decide this is my first carbon, this is going to be my second carbon, because I can't have this as a first carbon and count that way and end up this with this one as a fifth carbon. No, we have to number them consecutively. And like I said, by default, the first carbon will always have, it will always be on carbon, will always have is always the one that has the double bond. Okay, moving on, let's take a look at the next one. Which of the two is one may be determined by the nearest substituent group rule. Okay, so let's take a look at this example here. If I decide to say this is carbon number 1, okay, I have to make this one carbon number 2 by default, because they have to be numbered consecutively. So I have to count going that way. So this is carbon number 1, carbon number 2, and this substituent group will be on carbon number 3. Making sense that? Right. If I decide to make this carbon number 1, it means I have to count going this way. So this one becomes carbon number 2, carbon number 3, carbon number 4, and carbon number 5. If we look at the two ways of numbering this here that I've come up with, I'll end up with locate numbers such as for this here, I'll end up with 1 methyl, and I'm going to end up with 5 propyl for this one. 1 methyl, 5 propyl. If I add these locate numbers, they add up to 6. But if I come this way, I'm going to end up with 1, 3, which is the best possible option, because the sum of those locate numbers becomes 4, which works out perfect for me. So this is the best way to number that. So the question is, which one of the two is number 1 is determined by, you know, the locate number rules. We have to strive to get the lowest possible locate number all the time. Now, looking at this one here, what do we have? We can do the same looking at this one, but actually let me go on with the rules, because it's a lot easier. A carbon with multiple substituent groups should have the lower number than a carbon with only one substituent group. So let's take a look at this one here. This carbon here has got 2 methyl groups sitting on it. And this carbon should be my carbon number 1, because it has got 2 side chains, because this I'm going to have numbers such as, if this is number 1, I'm going to have 1 dimethyl. So that means I've got the lowest possible number that I can assign to this here. Right, now I have to decide to count either clockwise or anti-clockwise to see which one will give me the lowest locate number combination for these 2 remaining ones, because this one is already 1. So if I count this way, this one will be on 2, 3, 4, 5. If I count going this way, this one will be 2, 3, 4, 5. It doesn't matter which way I count. So preferably I'll just go this way, because I've got a butyl group here. It comes first alphabetically. That's why I'm coming this way. And this one is a propyl group. Okay. So this one here is cyclohexane, but it has got a methyl groups on carbon 1. It has got a butyl group on carbon 3 and a propyl group on carbon 5. Okay. The next one is the sum of all locate numbers must be the lowest possible. It's the same thing that we've been talking about, so I'm not going to go through this in detail. It's the same example I was giving here about those locate numbers. They must be the lowest possible combination that you can make. So if you have 2 different side chains, what you do is you list them in alphabetical order, and the first cited substituent becomes assigned carbon number 1. Or if you've got a scenario like the one I had here, where whichever way you count, you get the same locate numbers, lock and number combination, I went with one that came first alphabetically. Now let's take a look at it this way. If I had a compound like this here, it's a cyclic hydrocarbon. I've got CH3 here, and let's say I've got C2H5, right? So which one would I make my carbon number 1? So this one is an ethyl group, this one is a methyl group, so this one will be my first carbon, and I have to either count clockwise or anti-clockwise in the direction that will give this methyl group the lowest possible locate number. If the methyl group was sitting on this carbon here, which would be my carbon number 2, I would have to count this way. The methyl group is sitting there. If I go around 1, 2, 3, 4, this one gives me 4 for this methyl group, but if I go 1, 2, 3, right, so this one will be number 3. So the best way to count on this one is going anti-clockwise. So once you assign the one that comes first alphabetically, you assign it a locant number, and then you count clockwise or either clockwise to actually give the next side chain the lowest possible number. So this is what we're saying. Once you've done that, this is exactly what this point is saying. If you are taking notes, it's a question of just pausing and copying that, and you can also copy this example which I was giving here about which way to go once you've got the one that comes first alphabetically. Now the next point is, we now put the name together, listing the groups in alphabetical order and giving each group, a locant number. And then the principal chain must be given the name cyclo. This is exactly what we're doing when we're naming straight chain alkanes. We can also use prefixes di, tri, tetra if there are several side chains that are on the compound that you are naming. So like here, this one will be a dimethyl because we've got 2 methyl groups, so we've got a dimethyl here. That's what it means. Right, okay, so let's take our time a bit to name these properly before we close this session and come back to do skill practice activities. We say that this one here is a cyclopentene. We don't need to state the position of the double bond. This one here, we say this is going to be our carbon number 1, carbon number 2, carbon number 3. So the name for this one here is going to be, this one is a propyl group, P and M, M comes first, so it's going to be 1 methyl, 3 propyl, cyclopentane. It's correct name for this one. And let's take a look at this one here. This one, we say this is going to be our carbon number 1 because it's heavily substituted. So we have to count clockwise or anti-clockwise. We agreed that we're going to count this way because this one's a butyl group. It comes before B comes before P, which is our propyl group. So this one here, we've got 1, 1 dimethyl. Sorry, we don't start with this one, my bad, I just made a mistake there, pardon me, because methyl groups, methyl comes after B, M comes after B. It helps if I know my alphabet, but anyway, one of those things, it does happen. So we start with this one, 1, 2, 3. So this one is going to be 3 butyl dash 1, 1, because P comes after M. 1, 1 dimethyl dash 3, 4, 5 propyl cyclohexane, because it's and ANE. Sorry, this one is supposed to be ENE because our suffix is got double bond there, so it's 1-methyl-3-propylcyclopentene. This one is cyclohexane. Yeah, just to correct that. I think that's how we should name these ones here. Just to close this, we're going to do a bit more practice activity, a few more practice activities. I'm gonna take a break now because I think I'm getting a bit tired. It's about 10 o'clock at night now, so I should rest. I shall check on you next time when I produce the next video.